Welcome to CSC 243, Digital Communications and Networks. We did post the reconciliation for the Module 1 assessment, and we touched on how to work that process briefly at the very end of our class. I did, inside the resources folder, post the video from our Wednesday session for the item analysis right at the top of the resources folder. So that if you want to review any of the question items that we covered in class from that assessment, you have that available. We are pushing to see if we can get everybody to reconcile errors before tomorrow closes out. So that would be 11:59 p.m. Saturday. All you're doing is opening up a Word document, and nothing fancy here. And the trick when you open that Word document is to avoid the reflex to copy and paste. When you are typing the words, all we want for reconciled errors is for you to enter the words of the question by typing them with your fingers. And that's important because as you're typing in each of the letters of the word, your brain is working with that information differently. This has been proven by science. There are studies on this. So it's called tactile kinesthetics. And as you're working with your hands and your fingers and the mouse clicks and your eyes, and you're typing it out, and then you also enter the answer that should have been selected. You're not explaining why you selected something different. We don't want anyone groveling. This is not about demoralizing someone so they do better the next time. Oh, 3 demerits for you because you got it wrong. Shame on you. No, that's not it. We don't care about the concepts of the incorrect answer. All we want to associate as you type out word by word, letter for letter, the correct information is that your brain will associate the correct information with the question. If you do that for each of the items in the assessment and simply upload that document, then we will post another point of credit. So this is optional. And some people do very high on their score and they think, I don't have to reconcile. I would still recommend reconciliation because even the extra credit items, if there are mistakes, they tend to come back to haunt on the final version of the module assessment and in the midterm and final exams. So you want to be prepared and you want to do those things, even if it seems like hey, let's face it, if you only have 1 or 2 questions to reconcile and you get a full point more for doing that, that's easy work. That's low-hanging fruit. So I'm just making an appeal at the beginning of class. You won't hear this again. But even if you did well, unless you were flawless, you would not. And if you're flawless, turn in an empty sheet and say, I made no mistakes, even extra credit. And I will still post an additional point because you submitted for reconciliation. Okay? So we'll call it icing on the cake. And every now and then we have students that do that. And it's a delight for me to post that and say, what a bonus, exclamation point, right? So it happens a couple of times each semester. Is there anyone that has any questions about the expectations for our reconciliation? All right, hearing none. Over the weekend, I will post 1.6 assessment. That's the final version for the module. And I've also opened up module number 2, which is about the physical layer. And inside module number 2, on the cover page, you'll notice our learning objectives, right? And I want to talk to you about this thing called operational tenets. Sounds like the word tenant, as in like renter, but or occupant, but it's not. There's no N there. It's tenet. And the word tenet means principle or standard or best practice. And these are student learning objectives that come straight from the workplace. This is industry experience, just as you have two networking models, the OSI model from the world of research and engineering. You have an industry networking model that the rest of the world uses to get the stuff working. It's got 5 layers instead of 7. So what I'm saying is that there's 25 years of networking experience that I am including in this material that is not in your textbook, but there are references, indirect references to those principles along the way in the textbook. It's just that they're more embedded. So provide and assess electrical criteria required for a functional digital network. Now that's huge. And that you won't see a lot about it in Comer, but if you don't have a proper electrical ground, your networking will hit or miss. It'll be sputtery. It'll be like on again, off again. It's there, it's not. And we're going to talk about that and why that happens, okay? Because there's some electrical circuits involved, and a circuit doesn't work well if there is no proper ground. And explain how layer 2 is described, and common names that support personal use, right? Describe the trade-off between wireless frequency and transmission efficiency in plain terms. Now, this is something you'll see lots of YouTube videos about, and again, a lot of other stuff, but you won't necessarily see it in your textbook. So there's a good mix of additional references, cutting edge information, right? So we talk about 5G cellular. So this is the cool, I think this is one of my favorite modules because it's really like the nitty gritty physical layer, local network, transmission stuff, right? And this is where a lot of stuff breaks. One layer below is physical, but so we are going to see some references to physical along the way while we're talking about this, right? So some of our objectives dip back into the physical layer because there's an interface between the physical and the data link, and that interface is critical. If you don't have the handoff between the wire and the interface, it breaks. We'll also talk about methods of transmission on the wire, like modulation and multiplexing. So again, you have some layer 1 stuff mixed in here. Without further ado, let's click into the header of the cover page for module 2, right? Right here. And in our references, you'll see that there's a module 2 study guide. There's an addendum. There's a University of Michigan cheat sheet. We have more slides from the author. There's a reference about layer 2 technologies, and by that we mean the devices, the equipment, bridges, routers, switches, and such. Kind of like lions and tigers and bears. Oh my! Out of the Wizard of Oz. I might be dating myself here, and maybe you've never seen the Wizard of Oz. Has anyone ever seen the Wizard of Oz? I'm checking to see if you're like awake. Hello?
Yeah, I've never actually watched it. Just seen, clips, seen the Cowardly Lion and stuff like that.
Right, the Cowardly Lion. Yes, you've seen clips in YouTube about the Cowardly Lion. So Dorothy and her 3 imaginary friends from Wizard of Oz. Anyway, let's go ahead and get started with our first objectives. So you are going to be pushing ahead in the textbook in Comer, chapters 5 through 12. Now, what I'd advise is that you review that, glance through it, but then spend more time with the slides, okay? And there are some whiteboard diagrams on that screen I just showed you, especially the cheat sheet, okay? The cheat sheet. Really good. It's kind of like a gold mine And the University of Michigan, of course, is a major university, and they're one of the top 50 research institutions in the United States of America, and they have very powerful engineering programs. So provide and assess electrical criteria required for a functional digital network. Let's talk that up for a minute. So when you're talking about networking, the know-how to make that happen requires a mix of knowledge, skills, and abilities, which includes more than one discipline. Notice here, mathematics, right? And it's sort of the foundation, right? Math is the language of physics. So if you're doing physics, you're speaking physics in mathematical equations much of the time, right? And then apart from that, we have a specialty area. So physics is about the theory and the concepts, but making all that happen is the wonderful realm of the electrical and networking and electronic engineer. So we have engineering, and it's not just electrical, it's also electronic and network engineering. Okay? And we just wanted you to understand, when you're talking about data communications or networking, see how they intersect right here in the middle? All three disciplines lay claim to contributions that have changed our lives. And the world we live in right now, as we know it, would simply not exist except for these pioneers. Just want to call that out. Now let's talk physics first, okay? Physics first. So in the physical world, a proper electrical ground is required for electrical pulses to flow reliably. That's because in a circuit, a complete loop, electricity flows only when a circuit is complete. If the circuit is broken, then it can't flow. It's kind of like the light bulb being on or off, where the connection is there or not. Ultimately, all electrons, moving electrons, which is, and is everybody familiar with the term electron?
Yeah.
Parts of the atom. So there are other parts in the nucleus, but the electron is the one that rotates around the outside, kind of like the planets rotate around the sun. Does anybody remember what the name of the subatomic particles are in the nucleus of an atom? Anyone?
Yeah, protons and neutrons.
Excellent. Yes, thank you. Protons and electrons. Protons are positive and opposites attract. So the electrons like to stick around that nucleus unless they're a metal and there's lots of other electrons and they don't like each other. And so some of them like to jump ship. And when they jump ship, they start moving and flowing. The important thing to understand is that there's two criteria with flowing electricity. When you're talking about electricity that flows, I want you to think about water. There's a lot of parallels between a fluid substance and electricity that's flowing, because you have potential electricity, like the electricity in a battery, but you also have active electricity or kinetic moving electricity. The current or amount of flow of those electrons is referred to and measured by a unit of measure called the amp, which is short for ampere, A-M-P-E-R-E. Amps, plural. This is what kills a person. Let me repeat that. This unit of measure is responsible for the charge that stops a person's heart. And it does not take very many electrons flowing to completely ruin a life. You can stop a human heart with very little flow. It's not the volts. Now the volts refers to the pressure behind the flow. So if we were talking about water, this would be like the gallons that are delivered every minute, and the pressure would be how many pounds of pressure behind that water, you know. If you're into plumbing and you know what I'm talking about, that might help as an analogy. The important point to remember is that you can have a lot of pressure and you can have very little current, and it can really make for an interesting result, right? So what are some examples of that? If you've ever seen lightning or spark, there aren't often a lot of amps, but there's hundreds of thousands or even millions of volts behind that, which is why it's able to jump a distance. Ordinarily, electric doesn't jump through air. Air is a non-conductor. Air doesn't allow for electricity to move. So materials that allow electricity to flow are called conductors, and those that allow electricity to stay where it is, the electrons to stay where they are called insulators. Amps measure the amount of electrical flow, volts measure the strength or potential of the electrical flow. Too often, the physical layer is assessed without checking the proper ground and checking for proper voltage. So if you don't have a ground, the flow can't complete. It's like the water cycle where you have rain, and then you have streams on a mountain, and then you have rivers, and then you have the ocean, and then you have the sun evaporating the ocean, then you have the clouds, and then the clouds rain again. It's a water cycle. If you don't have a ground, the flow cannot happen properly. Also, if you don't have the right amount of voltage, the flow cannot happen properly. Any questions? Are there any questions that you can think of given the information I have shared? Okay, so this is one thing I'm going to tell you. We're going to move a little faster now. There's an electrical ground tester. It's got simple indicator lights. It costs about $7. And if you work with networking, you better have one of these. Let me say that again. If you're a network professional and you don't have one of these, shame on you. Because what you're not checking is the flow. If you plug in to the outlet where a Wi-Fi router is plugged in, or a network switch is plugged in, or a network device is plugged in, I mean, let's face it, any connected device with an electrical connection, and there is not a proper ground, that can seriously impair the reliability of the network capacity on that device. Now, the voltmeter costs a little more, and that helps you troubleshoot when you have issues and to identify other technical troubleshooting methods on the other layers. So what are we saying? The tester, the grounding tester, must show no errors, especially red indicators. So oftentimes you'll see yellow or orange. And then the voltmeter has to show a stable supply between 110 and 120. Now, when we say stable, what we mean is you plug the voltmeter into the outlet and you watch it, and it shouldn't fluctuate more than 1/10 of 1 volt every second or so. So it should say like 111.4, 111.3, 111.4, 111.3, or 119.2, 119.3, 119.2. That's the kind of fluctuation that's okay. If you have anything more than 1/10 of a volt fluctuating, you have some problems with your electric panel or the physical electrical supply. And if you don't eliminate those, you can go on buying more Wi-Fi routers every year. How many of you have bought more than one Wi-Fi router to try to get better internet? Anyone? Oh, come on, don't be shy. I'm being
Dr. Kenta,
yes,
sorry, I have a question.
yes.
So with the electrical ground tester, I know that with a multimeter, you get the functionality of a voltmeter on top of other things like checking for continuity. So would the multimeter include the simple electrical ground tester as well, or would that be separate?
Well, that's an excellent point. And the short answer is yes. If it's a good voltmeter with, and it has if it has the right features, the short answer is yes. The value of having a voltmeter and a separate indicator light is that if you have a condition right away, see, this is quick and easy. All you do is plug it in, you see red, you, oh, wait a minute, now I need the voltmeter. So it's like a first layer troubleshoot. And then the voltmeter can take it to the next level. Now, if you buy the voltmeter, what we find is that, well, people are kind of lazy. They don't break out the voltmeter until they think there might be something there. And what I want you to do as a professional is to carry this thing in your pocket, because if you don't assess the physical layer each and every time somebody complains about a network problem, you're going to be embarrassed sooner or later, and it's probably sooner. And well, so I appreciate that you asked that question. If people are comfortable and they carry a voltmeter around with them all the time, see, this is really portable and small. You can stick it in your pocket with a couple of other tools and away you go. A voltmeter, you start breaking that out, you know, things get more interesting. But yes, if you wanted to save a little money, you could buy a decent voltmeter, and along with the continuity tester, it would test for a ground. So I do appreciate the question. I still advocate having a separate meter, a separate ground tester. And let me tell you, if you have a ground tester that shows a problem and your voltmeter doesn't, either the ground tester is wrong or your voltmeter is wrong. And believe it or not, these are inexpensive components that often break. They get dropped, right? People drop voltmeters and such. So here you are thinking, oh, I don't have a voltage problem. Oh yeah, you do. Yep. And then, you know, a day and a half later, after you've checked all the other protocols, somebody else comes along and they just like turn a screw and everything works, and you feel really, really goofy. That's happened to me. So I would advocate having both if you can. But if you can only have one, the voltmeter does both. So good point. Any other questions? Tenth of a volt, that's all. Be sure that you always check these first whenever troubleshooting is required. Now, I don't care what the nature of the network problem is. I don't care what your users have told you. I don't care what the person who hired you says to you. You smile and nod and say, we're on it. We're going to get to the bottom of this. And you start with the bottom of this. I don't know if that's common sense, but I have seen people fall on their sword and lose their jobs over crap like this. So don't ever take for granted the electricity, especially with networking, cable networking, or with wireless, or even with fiber optics, because a fiber optic pulse doesn't work if the laser isn't working, and the laser is charged with what? Electrical. So, okay, now did you know a surge protector will not function properly unless a proper ground provides the means to shed the excess voltage? See, when there's a proper ground, the surge protector can shed or deflect the surge in voltage. But what happens if there is no ground or a poor ground? Some people sell surge protectors with a $10,000 equipment guarantee. It's a marketing thing. Oh, this comes with an insurance policy. If your equipment fries when you're using our surge protector, we'll replace the cost of your equipment up to $10,000. Have you ever seen that? Has anyone ever seen that on a surge protector? If you look closely next time, it'll tell you. Here's the thing. When that happens, and you try to collect to replace your flat screen TV and your stereo and your entertainment center and your gaming console and your, right, all that stuff, Wi-Fi router, the first thing they're going to do is they're going to send a qualified electrician out to your place, and what are they going to check for? A proper ground. And do you think the company's going to pay $10,000 if there's a problem with the ground? Yeah, that insurance policy has some fine print, and it says, yeah, well, all right, so we're going to send somebody out to assess. That's just important to understand. Now, a UPS is different. A UPS will also protect against brownouts where the voltage drops. A surge protector only protects against excess voltage. This is likely a root cause of some of the difficulties we're seeing on the St. Thomas campus as we speak. Because if there was too much voltage when the WAPA power was restored and the grounds weren't there, then things could fry. If there was a dip in the voltage, only a battery backup, a UPS, an uninterruptible power supply, will provide the necessary supplement to keep the voltage between 110 and 120. So a surge protector will not keep the voltage in the proper range. A UPS will. Now that's not information in here, that's just extra stuff. And I may end up revising this so it's revision 1A to include that information here. This is important. A common mistake by many is understanding that it's not the voltage that can injure or kill, but it's the size of the flow, the amps, across the vital tissue, the heart. So I'm just going to say that again. I should probably put that in red, huh? So since I've been here in August of 2016 and I arrived in the territory on island, I have read in the newspaper about 2 electrocutions where 2 of our citizens died. And they died because they didn't think the electric there could bite. It didn't seem like a risk. So that means a car battery can kill you. A car battery can kill you if you're grounded a certain way. It can really cause a problem. Okay. We're going to leave the wonderful world of electric, and now we're going to push as far as we can into student learning objective B and C. Neither of the formal OSI models, OSI or internet, refer to layer 2 as the MAC layer. But you do see that in the workplace. You'll see a lot of people talk about that's on the MAC layer. When they say that's on the MAC layer, remember that the MAC is really like an identity. The media access control value is a fingerprint. So it's really like an identity. And I like to think of it as an identity instead of an address. And that's an important distinction to understand, because an address, well, an address is, it's like an address, but it's also like a fingerprint. It functions in both ways. And because the MAC identity is supposed to be unique, it's one thing that helps establish the link between the physical and the interface layer, the network interface on a system. It does not change unless somebody's hacking and they duplicate the MAC address, which is surprisingly easy to do. And you know, if you're interested in seeing how somebody can do that, I can show it to you, but I would caution against where and how you use it, right? Okay, so one of the most prominent components that enables its functionality for most interfaces, since a physical link on the network interface is used to establish the MAC identity, it's broadcasting data frames, we often refer to the layer 2 as the broadcast domain. Now this is review from last module, but we're doing it again, and we're going to keep doing stuff like this where we take a deeper dive, and we want you to get exposed in layers, because networking has layers. It's like an ogre, and we don't want the ogre to scare you so you run off screaming from the room before the course is over. Welcome, Oskari. How are you?
Can you please repeat that?
I said, welcome. How are you?
Good afternoon. Morning. I'm good. Are you?
Good. Glad you could join us. So I'm recording this. You can catch the first part of it later, okay?
All right.
All right, so the MAC layer, the data link layer is the formal term for L2 of the OSI model. But in the other model, the 5-layer model, it's called the network interface. And that's, so layer 2 in both models has a distinctly different flair, for lack of a better term. And that's the formal term that industry uses on layer 2 to describe the second layer with the MAC address. Either way, you have a MAC address, prominent MAC address on that layer. Now, digital communication refers to the flows of ones and zeros between hardware components within the same device. So I'm going to make a distinction here, and I'm, for the sake of convenience, can everyone see my screen? Can everyone see my screen?
Yeah.
Yeah.
So this is the device manager in Windows, and it shows all the different physical hardware components within my system. Generically, now, okay, so there you're going to see some differences depending on which reference you use, online or textbooks. I want us to think of the term digital communications to mean the ones and zeros that flow between hardware components within a system or device. Okay. Now, I want you to think of networking as the flow of ones and zeros between systems, whole systems and whole devices. Now, that's just the convention that I would recommend in this class. But there are plenty of reasons why there are advantages to thinking in those terms after working in industry for 25 years. Again, you're going to find stuff on the internet or in Google or in a formal textbook where the definition will vary somewhat. But now you can also think of digital communication as the flow of ones and zeros generically, right? But then when you get between systems or between devices, now it's networking. I guess it would be fair to say that within the system, you have ones and zeros flowing until it hits the interface, right? And then it flows to different systems or devices. So you have the flow of ones and zeros. And if your formal definition of digital communication is only that, I guess technically you'd have the flow in ones and zeros all the time, but you have digital components in a system or device, and digital communication, that you can have misfires, and in terms of troubleshooting problems, it's often helpful to understand the components inside a device or system. So we break those down into 2 levels, and that's the distinction. That's why I'm saying I would prefer for everybody to see it this way. Any questions about that definition in particular? So when you have a medium is a substance between 2 devices or systems. Could be wire, could be glass fiber, which we call fiber optic. It could be radio waves, commonly called medium for one, or if there are multiple forms of transmission substance, we call those media. I just want you to know the proper terms because it's considered good form to refer to the proper terms. I don't want you to be, when you're talking with professionals and you're like, yeah, I had a class at the university in networking, you want to put your best foot forward. Okay. Now, frequency. We have pulses and we have waves. We've talked about that in the previous module. The higher the frequency or number of waves in a given second, that's called a hertz. So if you have 3 waves, and this works with water too. Water has a frequency, sound has a frequency. The number of waves that travels past any point in each second, that's called the number of cycles or waves. And the unit of measure is called hertz. And that's actually the name of a pioneer in physics and electrical engineering and math, right? Okay, so the greater the amount of data that can be embedded in a transmission. So the more waves you have, the greater the amount of data. The higher the frequency, the more data you can transmit. That should be that should be intuitive. If you have 10 waves per minute, you can signal 10 different ones and zeros in that same second, as opposed to just 2 waves per second, right? So in terms of bits per second, which we call BPS, bits per second, that's not bytes per second. A bit is a 1 or a 0, a byte is 8 of those altogether, right? As frequency increases, the wavelength decreases. Now, this is one of those things, it's called an inverse relationship. The more waves you pack together to pass a point, because waves usually travel in a specific speed, the speed doesn't change. The speed of a wave does not change. So if there's more of them passing a certain point each second, that means you have more of them, but the length of those waves is shorter. So the higher number of waves you have, the shorter the length of the wave. Smaller wavelengths do not penetrate certain physical objects and materials as well, and are completely blocked by others. So what am I saying? 2.4 gigahertz cellular signal or 2.4 gigahertz Wi-Fi is a lower frequency. Giga means billion. Mega means million. Kilo means 1,000. Gigahertz means a billion waves per second. When you have a billion waves per second, man, are they teeny, tiny, small wavelengths. And they go only so far through concrete and metal. But if you go to 5 gigahertz with the new Wi-Fi, wow, is it fast. Unless you got to go through a wall, in which case it is more completely blocked by the wall than the 2.4 gigahertz. So what am I saying? Buying a bigger, better, faster Wi-Fi router may not help your network speed unless you work some physical judo. And we're going to talk about that. If you've been frustrated with the speed of your internet in your home and you would like to double that, now is the time to rejoice, because I've spent 25 years fixing those problems, and I am happy to help you in your home get bigger bang. I mean, what's the point of this class, right? People say, what am I ever going to use this stuff? Well, yeah, you can use it right now. When you go home this weekend, there are some simple things you can do, and wow, will you have better performance. If you are interested in doing this for additional credit just to do it, I would gladly entertain a side project, and your family will think you're a superhero because it's like, wow, this is so much better. So I'm just putting that out there in case. Now, Wi-Fi distance for transmission in the open, in the air, for any of those frequencies tends to be about 300 feet or less. Think the length of a football field or soccer field or less in ideal circumstances. When there's other materials in between, it can be less. Cellular, WiMAX, and certain microwave frequencies can travel further than 5 gigahertz, okay? Now, this is something I'd like to mention here, and then we'll stop. On Monday, we'll talk about the dangers and the blessing of multi-home devices, but we won't do that today, because today we're focusing on medium, the stuff through which data waves travel, right? Unlike other types of media, optical fibers can carry signals over a much greater distance, up to 100 kilometers or 62.5 miles per cable. That's because they use lasers. Lasers are a technological advance that put all of the light waves in sync with each other. It's called coherent light waves. The coherent light waves are all aligned with each other. So the peaks and the troughs are all aligned together. And when you do that enough, instead of having a flashlight where the waves are all over the place and you have white light everywhere, which, by the way, white light is a combination of all the colors of the spectrum. A laser is a specific color. All of the waves are together. And because they're all together, it tends to ricochet inside the polished surface of the glass. So it's a bouncy ball that keeps ricocheting down the glass fiber. And single mode fiber provides a dedicated data channel that can travel longer distance without repeaters. Multi-mode fiber, and this is fiber that has multiple strands, provides several channels, right? And well, okay, so it's not always about the number of strands, but when you're running multi-mode fiber, there are several channels for the data to travel there. It just can't travel as far. It's convenient for campus and metropolitan installations like UVI campus, because the distance, you can run that far from one end of the campus to the other. You just can't go 62 miles. So, and if you have multi-mode fiber with several channels, one fiber can carry, I don't know, 10 trunks or 12 trunks or 20 trunks instead of a single trunk. So multi-mode is good for some installations, single mode is good for the distance. I want you to understand the difference between those two. When more data is needed, now here's the part that I want you to understand. Here is the part, here's the secret sauce. Here's where fiber is like a never-ending gold mine. Once the fiber is in the ground and the optical fiber is there, when you're ready for faster, better service, you just change the color of the laser. I'm going to say that again. Once the fiber is in the ground, you never have to upgrade it again. You don't, because if you change from like green to blue, now you're carrying 100 or 1,000 or 10,000 times the amount of data, simply because you used a different color laser, which can carry exponentially larger volumes of data. Now, when we say colors, which ones are the slower colors and which ones are the faster colors in that sense? Well, what I want to do here as we close our class is to talk about the rainbow. So I want you to notice my search string here. Visible colors, spectrum, electromagnetic, those 4 terms, right? Can everybody see this?
Yeah.
So here it shows you orange has a wavelength of 585 to 620 nanometers. Now a nanometer is like a billionth of a meter. Okay. So wow, that's a pretty high frequency, but yellow is shorter than that. See, it picks up where the 585 is. So yellow starts with 585 and runs down to 570 nanometers per wavelength. Green starts at 570 and runs down to 490. Blue starts 490 to 440. So what happens is that because you have higher and higher frequencies, you can do more and more data. That's the thing I want you to understand. And I want you to memorize the basic colors in their order from slowest to fastest: red, orange, yellow, green, blue, indigo, violet, red, orange, yellow, Roy. Everybody, repite usted, por favor. Roy. Oh, come on, humor me. We're almost done. I'm gonna close the screen after this.
Yeah, Roy.
Roy. Everybody, unmute your mics. Roy.
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 This is basic training, right? This is, you're in a boot camp now. G.
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 Blue, indigo, violet. Biv. Biv.
Biv.
Biv. Roy G. Biv. All together.
Roy G.
Roy G.
Roy
Biv.
G. Biv.
Roy G. Biv. Those are the colors in order from slowest to fastest. And if you have a violet laser, it's carrying a lot more data than a red laser, which is carrying a lot more than an infrared laser, which is over here and it's invisible. Or a UV laser carries much, much more than a violet, because ultraviolet can't even be seen, right? And you've heard those terms before, right? Infrared, ultraviolet. Okay. So now you know the rest of the story. Can anyone think of any quick questions or points of curiosity might be fun to ask after the information presented? All right, we'll end your suffering.